Hello. Now, when SlipSoftNet-based reliable embedded system design paper appeared on the IEEE Explorer, I can focus on prototyping SlipSoftNet computing-based embedded systems using SlipSoftNet machines and other facilities. Today we focus on the development in the environment of FreeRTOS together with Raspberry Pi Pico software development kit. So you can find more information on the SlipSoftNet computing in manifold papers published, and we have experience of developing embedded applications. So let us start with this brief introduction. So we have embedded system represented with SlipSoftNet, and input places mapped into sensors, output places mapped into actuators, and some additional papers for interaction with high-level systems. We are going to control this shop of automated manufacture that includes a robotic arm, a storage represented with a palette of blanks details, and rotary table where processing of information, processing of details takes place. Today we focus on control of the robotic arm, which is represented with a series of pictograms for its basic loop, and the control algorithm is specified using a SlipSoftNet. Here we provided additional numbers for sensors and actuators. And taking into consideration this program, we developed an application for FreeRTOS. First, we simulated it in Linux, and now we prototype using hardware to replace sensors and actuators of the robotic arm. So now we consider how we apply it in our cloud. We are using Linux implemented in Azure Cloud, and here, for instance, we can consider our program using editor Nano, and you can see that beside the code which is required to provide communication with LCD and Keypad, it is rather specific and reflects basic actions of our model, and we can make the corresponding code, and we can print it the content of the obtained files. Here we can see application app.uf2. It is code for the Raspberry Pi microcontroller, and we have another window without remote access, so we use this scp command to copy it from the cloud to our computer. And then when we press the corresponding button of our microcontroller, we use simple copy command to put it to our microcontroller. Maybe now I would like to return to the code, because at the bottom of the code you can find a complete trace of this prototype work with respect to the notation of actuators and sensors. For the previous simulator we were having mnemonic notation. Here we have numeric notation because we are using LCD of the limited capacity. So we can see that trace of simulation starts with this actuators number 6, and let us consider now how our prototype works. So here you can see Raspberry Pi, LCD and the Keypad connected, and now the actual actuators transmitted to the plant is actuator number 6. That means lower pull down. When our system works correctly, the sensor responded as 6, and I press button sharp to transmit it. Then, according to this trace, we can see that 8 number of the corresponding actuator, and we respond with the sensor number 8 and press the corresponding button and proceed starting the actions. Sometimes two actions are implemented simultaneously. For future, we think about asynchronous implementation. Now we provide response of the sensors in the same cycle. So we provide 2 and 4, and then sharp symbol. It is transmitted to the embedded system. Now we respond using 6 and continue. You can observe the entire loop of our embedded system with this sequence of sensors and actuators and find out that it works correctly. After a while, we can attach real-life sensors and actuators of the robotic arm to implement the corresponding control. As I mentioned before, we can either implement embedded systems in the environment of FreeRTOS system, or we can choose Arduino for direct implementation. We can choose Raspberry Pi SDK for direct implementation. Though, from the point of view of reliability, the best way is to use SlipSoftNet machine implemented either on microcontroller for SDK, for Arduino, or on FPGA, because in this case there is no intermediate code between SlipSoftNet and its implementation. We can verify, we can update our specification and immediately upload it to the controller. Thank you, and please use SlipSoftNet reliable embedded system design in your practice.